mathematicians, it's Justin again, and welcome back to the Place Value Galaxy. In our last lesson, we practiced representing numbers in different forms while visiting the captivating crystal caves. Today, we're setting off for the majestic rainbow waterfalls. I can't help but wonder, what surprises might be waiting for us when we get there? The waterfalls are known for their shimmering colors, but something tells me there's more to discover. By the end of today's lesson, you'll be able to understand how the value of a digit changes as it changes place value position. Additionally, you'll be able to represent the same value in different ways by renaming numbers. Have your guided notes ready, and let's go explore at the Rainbow Waterfall shore. Let's take a closer look at how the value of digits compare when they change place value position. We're going to follow the digit 1 as it flows through the place values in the rainbow waterfalls. This little fish is in the ones place and has a value of 1. Ooh, here comes some more. 2, 3, 4, 8, 9, 10. Looks a bit crowded with 10 in there though. How can we help them out? Yeah, let's regroup. 10 ones is the same as 1 10. Here come even more. Now we have 10 tens. Again, way too crowded. There we go. 10 tens is the same as 100. Are you noticing a pattern? How many hundreds will we collect before we need to regroup? 10. That's because each place value is 10 times greater than the last. And there they go. 10,000s become 1 10,000. So a digit becomes 10 times greater each time it moves to the left on the place value chart. What do you think would happen if a digit moved 2 places to the left instead of just 1? Pause here to record your thoughts in your guided notes. Well, we move 1 place to the left, which makes the value 10 times greater. Then we move another place, which is 10 times greater again. Since 10 times 10 equals 100, when a digit moves 2 places to the left, its value becomes 100 times larger. But wait, what happens when we move to the right on the place value chart? Hey, our little fish is back, and this time it's swimming in the hundreds place. Right now, it has a value of 100. But what if it swims 1 place to the right? Ooh, now it's in the tens place. Its value just got smaller. Instead of being worth 100, it's now worth 10. What do you think is happening to the value of the digit as it moves to the right? That's correct. As we move to the right, each place value is 10 times smaller than the one before it. So what would happen if the fish moved 2 places to the right? Well, let's keep going. The fish moves again from the tens place to the ones place. Now its value is just 1. Let's break that down. First, it moved from the hundreds place to the tens place, which made it 10 times smaller. Then it moved from the tens place to the ones place, making it 10 times smaller again. Since 10 times 10 is 100, moving 2 places to the right makes the digit 100 times smaller. So, just like when we move to the left, moving to the right on the place value chart changes the digit's value. But this time it gets smaller by 10 times for every place it moves. Pause here to practice increasing and decreasing the value of more digits in your guided notes. With the number 7,000, the digit 7 becomes 10 times greater if we move it to the 10,000th place. If we wanted to make the number 7,000 100 times smaller, the digit 7 would move to the tens place. Nice work. Finally, let's use the power of the rainbow waterfalls to explore how flexible numbers can be. There are 1,300 fish coming down the falls, but it looks like there's a rock blocking the fall where the thousands can swim through. Let's help these little fish go through the hundreds stream. These 300 fish can swim through no problem, but how will we get the 1,000 fish through the hundreds stream? Ooh, I know. We can break the 1,000 into groups of 100 and send them through. But how many groups of 100 are in 1,000? 10. So 300 plus 1,000 equals 1,300. 1,300 is the same as 1,300. Numbers can be named differently depending on how they're bundled together. Here comes a group of 47 10,000 fish. They can't fit through in a school this big, so let's help them out. First, we'll separate 40 10,000s from the other 7 10,000s. These 40 10,000s need to be bundled differently. Let's try grouping them into 10 10,000s at a time. How much would that be? 10 10,000s is the same as 100,000. Since we can make 4 groups of 10 10,000s, how many 100,000s is that? 400,000. Wow. But what about the 7 10,000s that are left? Would it be possible to bundle them differently and send them down the thousands stream? 7 10,000s is the same as 70 thousands. What if we had to rename it as hundreds? Pause here to rename 70 thousands as hundreds in your guided notes. Since each thousand is made up of 10 hundreds, 70 thousands can be renamed as 700 hundreds. So, the original school of 47 10,000 fish can be renamed in many different ways, like 400,000s and 70,000s, or as 400,000s and 700 hundreds. Wow, numbers really are flexible. As we move across the place values and rename numbers, the name of the number changes based on the grouping, but the value of the number itself does not change. We're simply looking at the number in different ways by grouping it differently. So, what have we learned today, besides the fact that numbers can change and rearrange, just like the currents of a waterfall? Well, now you know that the place value of a digit affects its value. You also know that as digits change place value position, their values change. Finally, you know that the same value can be represented in different ways. Be sure to complete the practice questions and extension activities that go with this lesson to practice working with place value. And remember, mathematicians, in math, as in life, every effort adds to your success. See you next time. Hey.